hello everyone. You can see, as you can see, I set up a computer and I have a whiteboard here. Hopefully, I can give you a better visual lesson for this chapter. So today we are starting chapter 7. We're talking about energy. So the major things we're going to talking about would be energy, work, power, mechanical energy, potential and kinetic, work energy theorem, and conservation of energy. So the rest of the things on this slide, actually you don't have to worry about it. So we only concerned about up to conservation of energy. So what is energy? So usually if they're in a classroom, I would ask students, what's popping up when we talk about energy. The combination of energy and matter makes up the universe. Okay, matter is substance and energy is the mover of the substance. So there are many kinds of energy actually in the world. Heat energy, food has energy, light has energy, chemical energy, nuclear power energy. Okay, and also we have kinetic energy and potential energy. So in this chapter, the major energy we're talking about would be mechanical energy, which has potential energy and kinetic energy. Okay, we will be talking about that later. So before we talk about energy, I want to talk about one of the most important concepts in this chapter, which is work. Okay, what is work? Okay, if you think about work, you think about homework, the work you need to do, right? Okay, we talk a lot about that in our daily life. But in physics, work is defined as force times distance. So in our level, so this is our definition. So work equals force times distance. Okay, so that means in order to do work, we need to have force over a certain amount of distance. But there are several scenarios. Actually, I want to just talk a little bit about work. That means, okay, if there's no force, then we don't have work. If the distance is 0, we don't have work. Okay, so if you are trying to push something and then you push very, very hard, let's say I'm pushing this table, okay, I'm pushing very, very hard, but this table does not move, so I don't do any work on this table. Although my muscles are working very hard, but I don't do any work on this table. Okay, and if the force is the same direction as the distance, then we're doing positive work. Okay. And if the force and distance in the opposite direction, we're doing negative work. But if force and distance, they're perpendicular to each other, okay, nothing is done. So the work is 0. Okay. The unit for work is Newton. Okay, that's the unit for force. Distance, meters, unit for distance. So Newton times meters is going to give you joules. So that's the new unit. For work. Okay, so what indeed is work? Okay, work is the effort exerted on something that will change its energy. So work is a way to transfer energy or change energy, but work is not energy. We're going to talk about energy later, but so work is the way actually you can transfer energy. Okay. You could do work to change the speed of the object, or you can do work to change the height of the object. So those will be related to different kind of energy. So before we talk about energy, I want to give you an example about work. So let's say we have an object. Okay, this object has weighs 10 newtons, okay, and then you're pushing 2 newtons here this direction. You have a friction, which is 1 newton this direction. Okay, so we want to find out the work, and then you push this over to here. Okay, the distance the object moves is about 2 meters. Okay, so then how do I find a work? So how many forces are acting on this object, in fact? Well, we have gravity, normal, and we have frictional. Let's say this is a pushing force. So the work done by pushing force equals push force times distance. So which is 2 newtons times 2 meters is going to be 4 joules. Okay, the work done by friction is friction times distance. But since friction, distance, they're in the opposite direction. Distance going this direction, friction is going that direction, so it's negative. So negative 1 times 2 is negative 2 joules. The work done by normal force, you see here normal force is this direction and the distance is that direction. They are perpendicular to each other, is 0. The work done by gravity is also 0. It's because gravity is this direction, the distance is that direction. So they are perpendicular to each other. Work done by the gravity is 0 as well. Okay. So what do we mean by all these, positive work, negative work, and 0? So one thing I need to talk about is mentioned actually in this chapter is the reason why we learn about this chapter is the things we're going to define like work, energy, they're all scalars. Okay, remember so far we learned last chapter momentum, impulse, they're all vectors. Okay, so that's the first thing I want to emphasize. Work, energy, they're all scalars. Okay, so that's a nice feature about it if you don't like to deal with vectors, and then this is a very nice feature about what we're going to deal with in this chapter. So we're going to look at pretty much the same set of problems, okay, and then we're going to looking at those problems from energy and work point of view instead of looking at the forces applying Newton's second law. So by saying that work actually is a scalar. Okay, it's a scalar. But work has positive work, negative work, and 0 work. So 0 work means that there's no energy change here. If you have a positive work, that means the object is going to gain energy because of the work. If you have a negative work, that means the object is going to lose energy because of the work. Like friction, we know that if we have a friction does work, it's going to do negative work on it, and then the energy of the object probably is going to be loose. For instance, it's going to slow down, so the energy, kinetic energy, we're going to talk about later, is going to be less. Okay, so that's the work concept. But how do we find out the total work? Okay, the net work, since we said work is a scalar, so all we can do is we just have to add everything up. So 4J minus 2J plus 0 is going to give you 2 joules. So 2 joules, that means the net work done by all the forces acting on that object I just showed you is 2 joules. Okay, so overall the net work is positive, which means that, okay, so the object is gaining some kind of energy. Okay, so in one word, we're saying that work is not energy, but work is the way to transfer energy. So you can do all these multiple choice questions by yourself, okay, and looking at all the examples and try to understand it. If you don't understand it, you can come back to me to ask questions. Maybe I can, explain as a whole class through video or through the Blackboard discussion. Okay. The next concept I want to talk about is power. Okay, so the power, okay, measures how fast work is done. Okay, just like if you have a more powerful lawnmower, for instance, if you're going to mow the lawn, cut the grass, the more powerful one is going to cut the grass in less time. Okay, so we say something is very powerful, so we define power equals work done divided by time interval. So basically is work divided by time. So the unit of power is going to be joule. That's the unit for work divided by time. Seconds is going to give you watts. Okay, so unit for power is watts. Okay, There are some other units actually sometimes we use for power and we can see in our daily life. One example is kilowatts. Okay. The other one example is horsepower. Okay. So those are the common, they use the units for power, but the SI units is watts. Okay, so that's about it for work.